Hello everyone, welcome back to the series of complete DSA using Python specially designed for GATE DA exam. In this session, we will cover the last 30-year PYQ from the topic of growth of complexity functions. So let's start with our first question, that is from GATE 2015. So let me read the problem statement. Let fn equal to n and gn equal to n power 1 plus sin n. So two functions are given to us. Here n is the positive integer. Find which of the following statement is correct. So they provide us two statements over here. These two statements, and we need to find out which of these two statements is the correct one. We need to compare fn and gn. So fn is a very simple function, that is n only. We need to find out, okay, we need to little simplify the gn function. So gn is equal to n power 1 plus sin n. Actually, we must be knowing that, okay, what can be the sin n value. So sin n value vary actually from -1 to +1. So this is the graph of sine, and the value from -1, then 0, then +1. So the value of sin n vary from -1 to +1. We can put these different value over here and we can simplify little bit this function. So let me put it over here. So if I put the -1 value first of all, okay, in place of sin n, then what will be the gn function? So that will be 1 plus -1. So that is actually n power 0, 1 only. Okay, fine. So I just put -1 in place of sin n and I get this value from this function. After this, okay, let me put 0 in place of sin n, just trying to find out possible values of this function, okay, based upon sin n value. I'm putting 0 value. So if I put 0 in place of sin, this will be n power 1. Fine, okay. And what about if I put +1 in place of sin n? If I put +1, this will be 1 plus 1, that is n square. Fine, okay, these are the three possible value that can be for this function. Okay, fine, we can compare now fn with gn easily. So here you can see first option I'm looking, okay, fn equal to big O of gn. What big O says that right hand side will be either greater or equal to left hand side. Let me write over here, fn is less than equal to gn. Okay, so this is what big O notation says. Here gn is n, fn is n and gn can be out of these three values. So if I take these two values n and n square, for these two value this condition is satisfying. This condition is satisfying, but this condition is failing for first option. Okay, for this one, if gn will be 1, that can be 1 when sin n will be -1. So for that I cannot say that, okay, gn is greater than fn, because if gn is 1, how that can be greater than equal to fn, that is n. So this, due to gn value 1, this condition is not satisfying. So even a single condition is not satisfying, single case is not satisfying, we cannot write it like that way. We cannot represent it with big O notation because of this value of gn. Okay, so this statement is incorrect, first one. Let me check out the second statement. Okay, let me write over here. Second statement is a big omega. Big omega says that left hand side will be either greater than equal to right hand side. We know this thing. And now let me see if this is satisfying all the cases or not. So if you will notice carefully these two options, when gn equal to 1, gn is n. In that case, okay, this condition is satisfying, means fn is n, we know that is greater than equal to 1, yes, that is also greater than equal to n, that is equal to n. So for these two, this condition is satisfying or this condition is satisfying, but for this case, when gn equal to n square, this condition will fail. N is not greater than or equal to n square, so I cannot write fn equal to big omega of gn also. Why? Because of sin n, because of gn value of n square. Okay, even one single condition is failing, then you cannot represent it with that notation. So both conditions are false over here. First condition is false because gn value is 1. Second condition is false because gn value can be n square also. Okay, fine. Okay, so neither 1 nor 2 are the correct. So D must be the right answer. Let me check out. Yeah, D is the right answer over here. Fine. Okay, let me move on to the next question. If you have any doubt, you can write in the comment section. I will definitely reply over there. Otherwise, I'm moving to the next question, which is from GATE 2011. Let me read the problem statement. Which of the given options provides the increasing order of asymptotic complexity of functions f1, f2, f3 and f4? So 4 functions are given to us and we need to arrange them in increasing order. Smaller, greater, 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 like this way. So 4 functions are given. So it's a better idea that, okay, you take the help of the options. When more functions are given, then check out in the options which you need to relate. If you will see carefully in the options, you just need to compare f1 and f4 and f2 and f3. See over here, no need to compare every combinations of function. According to option, okay, you compare it, save your time. So f4 and f1, I want to see which one is greater, which one is smaller. So here is f1 and here is f4. Let me compare, okay. 2 power n and n power log n. So let me see which one is greater, which one is smaller. Let me apply my informal method. There is nothing common between them. I'm taking log both sides. So log of 2 power n here will be log of n power log n. Whatever is in the power, that will be come in the front. This is the property of the log, and into log 2. Let me take base 2 both side. Okay. So here also this will come in the front, log n into this thing now, log n. Base 2 you can write. So this is 1 actually, and here we left with n. Here we have log n square. Still, if we are not able to compare, again you can take the log both side. This will become log n, and this you will take log of this term, log n square. So this will come in the front. So this will be 2 into log of log n. Okay, 2 is constant, you can remove it. So this side we have log of log n, this side we have log n. We know that which one is smaller, which one is greater. Log n is greater, log of log n is smaller. Okay, so this is greater, this is smaller. So we need to write in increasing order. So f4 will first come, f4 will first come, and then f2. So you can see that, okay, these two options are out now because this is writing f1 first. So we are writing in increasing order. So smaller should come first. So out of these two options, one answer will be correct out of A and D. For here we can compare, okay, f2 and f3. Let me compare f2 and f3. f2 and f3. Let me erase this thing. Okay, let me erase everything over here. We know that now either these two options are out, and either this is correct or either this is correct. Now I'm comparing f2 and f3. f2 and f3, let me write over here. This is n power 3 by 2 and this is n log n. So first of all, according to informal method, whichever term is common both side, remove that from both the side. Okay, so let me simplify a little bit this. This I can write as n power 1 into n power 1 by 2. Okay, this is same as n power 3 by 2. Okay, and this is n log n only. I want to remove the common term. Make sure you first remove the common terms. So here there was a common term between this and this n. So make sure to remove the common term before applying the log. Otherwise you will get the wrong answer. In many cases you will get the wrong answer. Okay, now there is nothing common both sides, you can apply the log. Otherwise you can see directly also. This is actually root n. This is actually root n and this is log n. And you know which is greater, which is smaller. So root n is greater than the log n. Otherwise if you want to apply the log also, you can apply log n power 1 by 2. Here this will become log of log n, and this will come in the front 1 by 2 log n, and here we have log of log n. Constant you can remove, so you know that log n is greater than log of log n. So anyway you can see directly also here this is greater than root n is greater than log n, or still you can apply further, continue again, you can apply the log n and see which is greater, which is smaller. So this is greater, this is smaller. So I can say that okay, this function is f3. F3 should come first. So okay, f3 should come first, then f2. So A must be the right answer over here, because f3 must come earlier than f2 and f4 must come earlier than the f1. So A must be the right answer. Let's check out. Yeah, A is the right answer over here. Let's check out the next question. Let's keep solving the questions. This is very must to practice the previous year questions. So let me tell you one thing. If you are solving all the PYQs, then nobody can stop your below 1000 rank in GATE exam. Nobody can stop. If you say that sir, I solved my all the previous year questions, I have practiced, I have one time, I have applied all of them, then I am giving you guarantee you will get below 1000 rank in GATE exam. After that, okay, further you need to practice with the test series to bring the rank below 300. Okay, fine. Let me check out the next question, that is GATE 2008 question. Here consider the following functions. Which of the following statement about the asymptotic behavior of this function is true? So actually I'm comparing this function, which is greater, which is smaller. Big O says that right hand side is greater, and big omega says that left hand side can be greater or equal to. Okay, let me compare these functions now. I can compare them by using informal method. One thing you can see directly, say you take it as a thumb rule. Whenever you see the n factorial, you can this is approximately, you can write it equal to n power n. N factorial is approximately equal to n power n. Okay, so take this as a thumb rule. Let me give you one more thing, one more standard information before solving this question. See, n factorial is greater than 2 power n, and n factorial is smaller than n power n. Okay, so this is another standard thing you need to know. Even you can check out it manually also. See, this is right relationship between these three functions. 2 power n, how you will write 2 power n? 2 into 2 into 2 into 2, so on. How many times? N times you are multiplying the 2 in this case. What you are doing in the case of n factorial? You are writing n into n minus 1 into n minus 2 into n minus 3, so on up to 1, multiply with 1. So you can see directly over here, you are multiplying 2, 2, 2 every time, n times. Here also you are multiplying, these terms are n only, but here you are multiplying n minus 1, n minus 2, n minus 3 and so on. So these are greater as compared to this. We always check for large value of input, n value for large input, this is always greater than this. And what about this? This is all are n, all are n, all are n. So n you are multiplying n time. Definitely this is greater than this and this is greater than this. So that's why I write this. So you can note down this standard comparison. This is very means standard comparison you can note down, and this will help you. Let me erase this and try this question now. You can replace this otherwise n factorial with n power n, and when you see n power n, that is greater than 2 power n. Okay, so gn, I can write that gn is greater than fn. One thing I can write. Fine. Now let me compare, okay, fn and hn. So if from the previous question itself you know that 2 power n is greater than n power log n. We already solved it by taking log both side, and we find out that okay, 2 power n is greater than this. So this information already we have with us. If you forget, then you can go to previous slide and you can check out. Okay, we find out fn is greater than hn over here. We already compared these functions. Okay, now I can write combined way also this Gn is greater than Fn and Fn is greater than Hn. Fine, that's it. So now we know the relationship between these three functions. Let me check out the options. In first option, this is saying that Gn is greater than Fn. Big O means greater than equal to. So is the Gn greater than Fn? Yes, Gn is greater than Fn. This statement is right. What about this one? Here this is saying that Hn is greater than Gn. Hn is not greater than Gn. Hn is not greater than Gn. So due to this statement, this option is wrong. Okay. Let me check out next one. Big omega says that left hand side can be greater than equal to right hand side. So Fn is greater than Gn. Fn is greater than Gn. No, Fn is not greater than Gn. So this option is wrong. Fn is greater than Gn. Yes. Oh, no. Fn is not greater than Gn. Gn is greater than Fn. So Big O says that right hand side is greater. Fn is not greater than. This option is also wrong. Fn is greater than Hn. Yes, Fn is greater than Hn. You can see Fn is greater than Hn. And Gn is greater than Fn. See, big omega is there. So left hand side will be greater than or equal to right hand side. Gn is greater than Fn. Yes, Gn is greater than Fn. Both statements are right. This one also, this one also. So D is the right answer over here. D is the right answer. Let's check out the answer. Yes, D is the right answer over here. Fine, okay. Let's try the next problem. Practice is very much required for the GATE exam. Otherwise, just covering the theory will not help you. Believe me, if you really want the rank, then practice cannot be replaced. Fine, okay. It's better you people please pause all the questions. First try it yourself, then check out the solution. That is the best way of learning. Okay, that is the way of learning actually. So otherwise, I'm solving it. You can take the help. First try yourself. GATE 2008 question. Read the following statement. Arrange the following function in increasing asymptotic order. So increasing order, smaller, greater, we need to arrange. So many functions are here. You cannot make all the combinations with each other. So take the help of the options. You can take the help of the option. So if you will notice over here, if you will notice these last two, we are comparing everywhere in all the options B and E. So let's compare B and E only. Based upon that, we can eliminate some of the option from here. So B and E. B and E, we can see over here that okay, E value is approximately 2.7. Okay. So you know that okay, 2.7 power n, you're comparing with this. So this value is smaller than 2.7, power is same, n. Okay, you can see directly that okay, this one is greater. So B is greater than E. So E must come earlier. E must, okay, in the three options E is coming earlier. Here B is coming earlier. So this cannot be the option. We eliminated one option, okay. We eliminated one option. Now if we will see over here, most of the time you are comparing C and D. So let me compare C and D. C and D, let me compare over here. So C is n power 7 by 4 and D is n power log power n. Okay, so let me tell you, log of 9 power n is same as writing log n power 9. So this is same thing. Okay, both are same thing. So I want to compare these two now. Again, please remove the common term first. Whenever you are applying the informal method, first you need to remove the common term. So let me simplify a little bit it. This will be n power 1 into n power 3 by 4. Okay, fine. And here is this term. So n and n is common. We remove it. Now we cannot, we don't have any common term. So let's take the log both side. Log n power 3 by 4. Here I'm taking log of log n power 9. This is same as this thing. Okay, so whatever is in that power, that will come in the front. This will be 9 into log of log n. 9 is constant. Here we have this term, and here also let me simplify, bring it to the front. 3 by 4 into log n, constant you can remove. So now you can compare log n and log of log n. So log n is greater, we know log n is greater than log of log n. So this is greater, this is smaller. So smaller one is D. D must come earlier. If we compare this and this, okay, so D must come. So these two options are gone actually. This is already gone. This is also gone. Now D will come earlier, but D, still we need to compare A and D. A and D we need to compare. We have still two options. A and D we need to compare. A and D we need to compare. So let me compare A and D also. A and D, let me erase this board. And again, I am just applying the informal method which we cover in the last class to solve all the last 30 PYQ. Okay, we can solve any PYQ with it. Fine, okay, I am comparing here A and D now. A is n power 1 by 3 and D is actually n into log power 9n. Here you can see directly actually this is even smaller than n. N power 1 by 3 even smaller than n. Still this is multiplied by log n power 9. So definitely this is smaller, this is greater. So A is smaller, A should come first. So yes, A should come first. So out of these two, A is the right option. So this is also gone out. A must be the right answer. So it's a good idea that okay, you people compare the functions. You check out the solution options, whatever the option is given. From there you can see okay which functions you need to compare and you can eliminate the other options. So this will save our time rather than comparing each and every function. So A must be the right answer. Let me check out. Yes, A is the right answer over here. Fine, okay. Let me erase the board and move on. Let's check out the next question, which is from GATE 2003. So let me read the problem statement over here. Consider the following three claims. So three claims are given. Three functions are compared with each other. This is compared with this by using theta notation. And this is 2 power n plus 1. In the power we have power n plus 1. This is big O of 2 power n. And another one is this. We need to find out which of the following claims are correct. So let's check out first one. In first one, they are saying that K and M are constant. Here, K is constant, M is constant. If you will simplify this, which will be the largest term over here? In asymptotic notations, we are bothered about only the largest term. We are not bothered about the smaller term. Okay, we are bothered about the largest term. So the largest term here will be n power m because K is constant. So K power m will be smaller than n power m. And here we have, okay, theta of n power m. Yes, theta says that left hand side should be exactly equal to right hand side. Yes, they are equal. They are equal. So first statement is right. First option is right. First claim is right. Let me check out the second claim now. This is what? Let me write. 2 power n plus 1 is same as 2 power n into 2 power 1. So this is same as this. Now we need to compare it with big O. Big O of 2 power n. Remove the constant and check out. See, big O says that right hand side will be either greater or equal to. So here we have 2 power n. Here also we have 2 power n. So yes, I can represent with big O. Equal to, because equal to is there, so equal to can also be represented with big O notation. Okay, although I can represent it with theta also, but big O also support equal to. So this statement is also right. Second claim is also correct one. So let's check out the third claim over here now. Let's check out the third claim. Third claim says this thing is equal to big O of 2 power n. Let me see what this is. 2 power n plus 1. So I can write it like this way. 2 power n into 2 power n into 2 power 1. So is this equal to big O of 2 power n? So constant, I can remove. Fine. But here 2 power n and 2 power n, we are multiplying. This is this side and this side. This thing is common. But this is still greater than this. But big O says that right hand side should be greater than equal to the left hand side. But here left hand side is greater. See here we are functionally 2 power n greater than this one. Okay. So this statement is false actually. This statement is false. This relation is false. third claim is false over here. Okay, so which of the correct option over here? First and 2, 1 and 2. So A must be the right answer over here. Let's check out. Yes, A is the right answer over here. Fine. Okay, so let's move to the next problem now. Let's check out the next. Let's solve all the GATE last 30-year PYQs. So this is GATE 2000 question. Let me check out the problem statement over here. Again, we have some function with us. We need to compare them. We need to find out, okay, which of these claim is right one. So let me check out. Let me compare. First thing, okay, you can directly write this thing that, okay, this is approximately equal to n power n. Okay, n factorial is approximately equal to n power n. And actually this remains the largest function first of all. Although you can compare all of these three. Let me write all of these three. Fn is n3 into n power root n, and gn is 2 power root n into log n, and hn is n factorial, which is approximately equal to n power n. So now there is nothing common between them. There is nothing, if you can notice. So you can take the log, remove the constant factors also. This is 3 into n power root n. And this is in the power of 2. So this is not constant. Fine, okay, remove the constant, and now there is nothing common between them. So I'm applying the log over here. So if I apply the log here, n power root n, log over here, log of 2 power root n into log n, log of n power n. Whatever is in the power, bring it at the front. Root n into log n. This is also will come in the front. Root n into log n. And this log 2 will become 1 actually. Log 2 will be there. Log 2 will become 1. Let's take the base as 2 only. So fine, okay, here we get this. This is also bring in the front. This is n into log n. Here you can see directly now this root n into log n are same. They are equal. So I can say that, okay, Fn and Gn are equal. Let me write. Fn is equal to Gn. This thing we find out. And n log n is greater than root n into log n. So n is greater than root n. Okay, so definitely n log n is greater than root n into log n, because n is greater than root n. Log n is common, but n is greater than root n. So I can write that, okay. Let me summarize it. So Hn is the largest one, which is greater than Fn, which is equal to Gn. So this is the relation between these three functions, and based upon that, now we can see which of the statement is true. This is saying that Hn equal to big of Fn, means Fn is greater than Hn. Fn is greater than Hn. Fn is not greater than Hn. This is option is wrong. Here this is saying that Gn is greater than Hn. Gn is greater than Hn. No, Gn is also not greater than Hn. Hn is greater than both of these two people. So this is also wrong. Let's check out the third option. Here this is saying that Gn is not Fn. He want to say that, okay, Fn is not equal to big O of Gn, but actually Fn is equal to big O of Gn, because Fn and Gn are equal. Fn and Gn are equal, so equal can also be represented with big O notation. Equal can also be represented with big O notation. So this statement is wrong. I can write it like this. Okay, I can write like this. Let me write over here. Gn is equal to big O of Fn. I can write it like this because says that greater than equal to. Equal to is also there, and they are equal. Equal can also be represented with big O, big omega. Definitely theta represents the best way, but we can use big O notation also. If two functions are equal, then the relationship can also be defined with big O. So they are equal, Fn and Gn, and they are saying that we cannot represent Gn is not big O of Fn. So this statement is also wrong. We can write it in the form of big O notation because they are equal. Equal can also be handled by big O and big omega. Last one, okay, these three options are wrong now. Let me check out the last option. Fn is equal to big of gn, means gn is greater than fn. Gn is greater than fn. This statement is true. This statement is true. This statement is true because they are equal, and if they are equal, then that can be represented with the help of the big O notation. Yes, fn and gn are equal, so they can be represented with the help of big O notation also. So this statement is true. D is true. Let's check out. Yeah, D is the right answer over here. Fine, okay. Let's move on now. Let me erase the board. Any doubt is coming to your mind, don't hesitate. Please write in the comment section. I will definitely reply over there. Otherwise, okay, that's it for this session. We will meet back in next class.